Hi, so we're going to work on atomic symbols, subatomic particles, and the periodic table here. So we need to do potassium with 20 neutrons, and it wants the nuclide symbol, which looks like this. So potassium is K, 20 neutrons. If we look at the periodic table, we can find out that the potassium has 19 protons. So if we add our 19 plus our 20, we get 39. 39 goes up here. This is the mass number, which is the number of protons plus neutrons. Mass number. And then this is the atomic number down here, which is simply the number of protons. All right, so xenon with 78 neutrons. Xenon is Xe. If we look at the periodic table, we can see that it has 54 protons. 54 plus our 78 neutrons is 132. So that's what our nuclide symbol looks like for that atom. All right, so name each of the following elements and give the number of protons, neutrons, and electrons. So we have, this is copper. And it has a mass number of 65. So that means our 65 is our protons plus our neutrons all together. So we look at our protons on the periodic table. The atomic number is 29. So we have 29 protons. Our electrons should be equal because it is a neutral atom. And our neutrons, which I'm going to say N0, is 36. And that's because 65 minus our 29 equals 36. Okay, so this is Krypton. Whoops, K-R-Y. Krypton, like Superman. So we have 86. That's our mass number. So if we look at the periodic table, we can see that our protons is 36. Our electrons would be 36. And our neutrons would be 50. Because 86 minus 36 is 50. Okay, and the last one is nickel. And if we look at the periodic table, we see that nickel has 28 protons. I'm putting P plus. 28 electrons because they're neutral right here. 28 protons equals electrons. And then our 58 minus our 28 equals 30 neutrons. Okay, so hopefully you're getting the hang of it. We're going to move up. And then we're going to fill in this table. I wonder if I can move it over. Okay. So, our mass number, as you see, is going to be this number up here. For every mass number, we can just fill it in right now. 121, we have 23 down here, and then we have 80 down here. That's our mass number, always in the top corner there, okay? Now, the number of protons we need to look at the periodic table for. So we see that antimony, which is Sb, has 51 protons. If we look at the periodic table, we can see that 47 protons is silver. That's Ag. Okay? Now we look at the periodic table with 39 is yttrium. That's a Y. 38 protons is strontium. Mass number 127. We don't know yet how many protons it has. We can't look that one up. But protons of 92 would be uranium. And we have the mass number right here, 238U. Actually, we had the mass number of strontium too, so we could stick it up in the corner there. All right, so we have sodium. This has 11 protons from the periodic table. And bromine has 35 from the periodic table. So we can tell that right away. Now, our mass number is the protons plus the neutrons together. So 51 and 121, if we subtract these, we see that we have 70 neutrons, right? Because 121 minus 51 is 70. Okay, and there's no charge here. It doesn't look like there's a charge. So we're going to say the charge is 0, and our electron should equal our proton. So that's 51. Now, silver. we have 47 protons plus our 61 neutrons should be a mass number of 108. So that 108 goes up here. 108. Okay, and our electrons should be equal to our protons because it has a charge of 0. Now, yttrium. Protons plus neutrons. 39 plus 50 should give us 89. And we put the 89 up there in the corner. Our charge is 0, so we don't worry about that. And our protons equal our electrons, so that's 39. Now, strontium. We have a mass number of 88. Our protons is 38, so our neutrons should equal 50. Because 88 minus 38 is 50. Now, our electrons are only 40, but our protons are 38. So if we do our regular formula of protons minus electrons, or if we just compare, like there's 2 extra electrons, our charge is going to be 2 minus on this. I mean, not 2 minus. 2 minus. Strontium, 2 minus. 2 minus on that one. All right. So mass number 127, we don't know what this is yet. But our neutrons are 74. So if we go 127 minus 74, we end up with 53 protons. And if we look at the periodic table, we know that it is iodine. So we put our mass number up there, and we have iodine as 53 neutrons. Now our charge here is -1. That means we must have 1 extra electron. So that means 54 electrons. Okay, and gives us a 1 minus. 238 uranium, 92 protons. Neutrons, we have to do 238 minus 92, that gives us 146. Our electrons, since the charge is 0, equal the protons at 92. Over here, we have sodium with 23 in mass number, and our protons are 11. So our neutrons are 12 because 23 minus 11 is 12. Our electrons, well, we have a positive 1 charge here. So we're going to put a positive 1 here, or it could be 1 plus, it doesn't matter. And then we know that our electrons are going to be 1 less than our protons. Our protons win here. They're positive. So we have 10 electrons. Does that make sense? Now, we have 80 as the mass number. Protons is 35. We have a negative sign, so our electrons is going to be 36 because we have 1 minus here. And our neutrons are just going to be 80 minus 35, which is 45. Okay, so that's how we just fill out our table. You just kind of have to do each one individually, the mass number. I don't remember why I wrote this here. We don't need this here, this 2 minus. The 2 minus means that there are 2 extra electrons versus protons. All right. See you in the next video.